Hey guys, welcome back to Algebra 2.1. Let's get started on the quiz review. But before we do that, I have a couple of things that I want to get to first, which is really just the homework quiz and the Desmos activity. So let's go through Bellwork. That's the first thing that we're going to be doing, guys. Bellwork, then the homework quiz. And then after that, I have a Desmos activity for you guys to go through. I'll give you the code once more. I want that to be done no later than Friday by 4 p.m. And then I'll give you some time to work on the quiz review, and then, of course, the summary, closure, and homework. Okay, so before we get, you can start writing these down, but before I go through them, yes, you should be preparing for the homework quiz, absolute value equations and inequalities. That's on Math Excel. Make sure you have done the assignment first. I mean, it's just, again, you don't have to, but it's way better to do the assignment first. Remember, I'm checking your assignment to see if it's completed by participation on Friday. Remember to keep checking in with me like you guys always do, so I appreciate that. Also, Math Excel. So as you guys are writing this down, just the Math Excel orientation due Friday by 4 p.m. And then the pretest due Friday by 4 p.m. Make sure all the homework assignments and all the homework quizzes are done by 4 p.m. I will take points off, so make sure you are actually doing Math Excel stuff. You need to be doing Math Excel stuff. If you have any other questions, like I said, over and over and over again, make sure you talk to me. The only thing I can probably think of that's maybe a lot of you still haven't done is the Google Classroom. So hold on, just give me a second. Google Classroom, what is your Math Excel login? A lot of you have yet to do that. I don't know why, to be honest. Make sure a lot of you, like a good majority of you, still need to do this. So make sure you do this, please. Okay. If you're not on Math Excel, then you need to get on Math Excel. That is very dangerous because if you're watching this video, it's more than likely Thursday. This is the day that you're technically supposed to be on the quiz review. So if you're on Thursday watching this and you're still have no idea what's happening or whatever, then you need to talk to me ASAP or else you will flunk your first week. That's unfortunate. You really shouldn't do that. So, all right, let's get started here. I want to go through these. These are questions that you'll see on your homework quiz. Not the exact same numbers, but the form, the process, the basic structure of the problems you will see. So let's get to it. Now, yesterday when we went through the actual absolute value equations and inequalities lesson, we finished that. Most of the time, the absolute value part was on the left side, and we actually structured our formulas so that it would work if the absolute value part was on the left side. Clearly, right now, it's not on the left side, so what am I supposed to do? All you have to do, guys, is flip it. Okay, so that means you flip it like a pancake. Everything stays the same, but you flip that sign. So instead of a less than or equal to sign, it actually becomes a greater than or equal to sign, and then 6. So now you have this on the left side, and it can actually follow our template. Now, before we actually go through that, is it isolated? Yes, the absolute value part is isolated. We don't need to divide or add or subtract or anything like that. So we're solid. The second part I want to think of is which sign and what kind of form does this sign, this inequality sign, tell us to kind of perform? What kind of formulas am I going to be producing based off of this inequality sign? Well, this is a greater than sign, which means I will still have two equations here. Not equations, sorry, inequalities. I will still have two inequalities here, but the first one is actually the easiest, 3x minus 3 greater than or equal to 6. Exactly how you see it, except for the fact it doesn't have the absolute value bars. That's my first equation. This is following the greater than formula. If you don't remember what that is, I'm reviewing it right now, but if you also don't remember what that is, just go back to the previous video. All right, what is the second equation? Well, it is exactly how I see it, but it has a couple of differences. Those differences are as follows. It changes the sign from greater than or equal to then a less than or equal to. And it also gives me a negative on that constant. So those are the only two things that it really changes. Okay? So now they're just like normal inequalities, right? We can solve it as such. So this is 3x greater than or equal to. This will be 9, which means x is greater than or equal to 3. And notice how I'm not switching the sign at all or anything, okay, because it's not divided by a negative or anything, or multiplied by a negative. This second one here, let's add that 3 over. So I have 3x still less than or equal to. If I add the 3 over, this actually becomes negative 3. Divide by 3, divide by 3. I'm dividing by a positive 3, so I'm not changing the sign here. It's still going to be less than what I originally started with right here. This is negative 1. So remember that these are OR inequalities. Now solve the absolute value inequality. It doesn't say anything besides solve the absolute value inequality, but for the sake of laboring the fact, I do want to give you the number line. Wow, that is literally a perfect straight line. And I straight up just, that was amazing. Look at that. I almost want to take a picture of that. I'll take a video instead. This is negative 1, 0 for reference, and this is 3. So let's look at what this is doing here. So negative 1, it is a closed dot because it's equal to, and what side is it pointing? It's pointing actually to the left, so I'm going to shade all the way to the left. And then the 3 is also shaded in, closed in, and it's pointing to the right. So remember, this is what we call an OR inequality. So either that or that. It's OR inequality. So that's probably the first thing I'll ask you to do. The second thing I'll ask you to do is find your interval notation. So I'm going to write that down. Find your interval notation. What is your interval notation here? All right, let's do it. So your interval notation, where does your graph start to exist, the shading part, where does the shade start to exist if you read it left to right? So left to right, left to right, okay? If you're reading it left to right, then you should start with negative infinity. Now remember, infinities always, always, always have parentheses on them. And negatives always, always, always come before positives because you're reading it left to right, okay? So, negative infinity all the way to, where does it stop? Where does it stop? It stops at negative 1. Is that going to be, don't forget your comma, is that going to be closed or open? It's going to be closed, so bracket. How do I jump? How do I jump between one value to the next? I have to use my union. So I use my union here. And now where does it start? Well, it starts from bracket 3 all the way to what? Positive infinity. So I'm going to write positive infinity here. That is my interval notation. Sweet. That's supposed to be a smiley face. That's a little bit better. That's dimples. All right. I'm going to erase. Let's move on. Let's do it. All right, this one looks complicated, but again, I assure you it's not. The first things first, you got to separate these values. So this is multiplied here, that's added. So let's subtract 11 first. So then I get 2, absolute value, 8 minus 5 all over 2, x, absolute value, equals, if I subtract 11 here, that goes poofy, and on the right side, it actually is 14. And then I want to divide by 2 to isolate this because that's multiplied. Divide by 2, I want to just isolate it. So now my isolated absolute value equation, because this is an equation now, not an inequality, notice the difference, that becomes 7. So I have an equation now, okay? Equation. I have an equation. So let's try to solve it. What do I have to do in order to do the equations? I still have two values, two solutions. I need to separate them using my general formula that we learned in the last video. What is that general formula? Well, the first equation is literally exactly how I see it, except for the fact there's no absolute value bars, okay? The second equation right here, I'll actually do all the way over here, so I just have enough room for both. I just want enough room. The second equation is literally exactly how I see it, except for the fact it has no absolute value bars and it has a negative tagged on. That's my second equation. All right, let's start solving this. The first one, what do? Well, I have to subtract the 8 over, of course. I need to solve for x. That's what I need to do. So if I subtract the 8 over, that becomes negative 1. Now what do? Well, I have to multiply by the reciprocal, so negative 2 all over 5. What I do to one side, I must do to the other. So that goes poofy, that goes poofy. I'm left with x equals, the negatives go to town on positive, so I have 2 over 5. Perfect. Perfect. So that's one of them. Let's go to this one. What do I do for the second one? So if I subtract the 8 over, I have negative 5 all over 2x, and this becomes negative 15. And so I need to multiply by negative 2 all over 5, and then negative 2 all over 5. Did we do this assignment? Not assignment. Did we do this one? I feel like we did this one. Either way, it's good practice. Okay, so you can see how it works. This goes poofy. This becomes x. That becomes a positive, and then this actually is over 1. So that divided by 5 is 3, and divided by 5 is 1. So this is actually a positive 6. I feel like we already did this example, but that's okay. All right, the graph. What's the graph going to look like? If we already did this example, it's not that big of a deal. I'm not too upset about it. That's what the graph will look like. I don't even think we need a graph. It literally equals this and this. I don't think you actually need a graph here. I don't know what I was thinking, but I really don't think you need a graph. I think you only need a graph with inequalities. So with equations, that's what it would look like. There's no shading because there's no less than or greater than. So that's what the graph looks like. And then the domain is, yeah, I don't think we need to do the domain at all. No, I don't think we need to do the domain. So that's it. Smiley face, check mark, unicorn. Let's go to our last one. Okay, so that was an equation. Let's erase. I think the next one, yep, the next one will be an inequality. Let's do the inequality. And again, I will graph the inequality. Equations, you don't need a graph, you just need the solution. But for inequalities, I think you do need a graph. So first things first, I need to isolate it. So subtract 2. So if I subtract 2, this will then become 6. And then I'm going to just divide by 2 right now automatically. So I know I'm doing a lot of steps in one because I want to make sure you guys don't waste your time on this video and actually get to your homework. It's greater than, notice it's a greater than, and this is 3. Perfect. That's a 1. Now that's isolated, my first equation, my first inequality, it's exactly how I see it, except for the inequality, the absolute values. Second inequality, exactly how I see it, except for the fact that that's not right. I have to change the inequality sign and a negative. Perfect. Let's do it. If I add 1, this is 2x. Add 1, this is going to be 4. Divide by 2, so x is greater than 2. Perfect. If I add the 1 over, this is going to be 2x less than. If I add the 1, this is negative 2. Divided by 2, divided by 2. This becomes x is negative 1. Perfect. Let's graph this out. Negative 1, 0 for reference 2. And what this will look like is open dot, that points this way, and then the 2 points this way, which means it's an OR, which means when I want to find my domain, it'll be negative infinity because it's all the way to the left, stops at negative 1, open, so I need to include parentheses here, union, so I can jump, and then this is 2 all the way to positive infinity. That is what my domain would look like. Sweet. I love it. Good stuff. This one looks familiar too, so I'm not really sure if we did this one too. I don't really care. All right. Pause it if you need to use it, or still write it. I'm going to erase. All right. Now you are going to go on your homework quiz, absolute value equation, absolute equations and inequalities. Okay, so what will this look like? It will look like 5 questions, 25 minutes, of course, open notes. Again, I want to stress this because a lot of you didn't take the opportunity to do this in the last homework quiz. Send any partial credits. If you look through your 5-question little quiz and you messed up a couple of times, where maybe you put a negative when it was really a positive, or you put a bracket when really it was supposed to be a parentheses. Okay, I don't know what it would be. Whatever it is, you can definitely send me an email saying, "Hey, can you check this for partial credit?" And I could possibly give you partial credit. I mean, that's just a silly mistake. If you have a 7 though, and you meant somehow to be putting a 5, and you email me like, "I really meant to put a 5 there," when the 5 is the right answer, I'm not going to accept that. That's not a partial credit request. A partial credit request is if you accidentally put X instead of Y, you accidentally put negative instead of a positive, parentheses instead of brackets, stuff like that. Maybe you put infinity, like you did it like this instead when it was really supposed to be 5 to infinity. I don't really want to give you partial credit for that, but it is still technically correct, as in you had the right idea, but it's still false. Okay, that still doesn't make any sense. So I probably won't give you too much credit for that, if any at all. But I'm just saying this kind of stuff, you can send it to me and I can actually help you out with your homework quiz. Remember, if you did the homework assignment at 100%, that gives you +2 extra credit points towards the homework quiz, if it's done on time and before you take the homework quiz. After you finish that, please finish or start the Algebra 1 quiz review. That's about 15 questions. Okay, it's about 15 questions. It's obviously going to be on Math Excel. Make sure you complete that. And then if you have done that, if you completed that, then go on to Google Classroom and please show me, or at least tell me or tell yourself whether or not you've done that. Also, go to Math Excel. Have you done the Math Excel orientation? Have you done the pretest? Have you done all the other assignments? If you have, then you should go finally down here to the quiz. Okay, you should do these. Remember, if you're honors, you're only doing honors. If you are not honors, you will not be doing honors. Don't do honors. If you're in honors, again, you don't need to do both of them. So don't feel like you need to do all of them. Just do the honors one. So go ahead and pause it if you want. Do the homework quiz right now if you want to. You should. After you're done with the homework quiz, you're going to be doing this Desmos activity, and I want this to be done by Friday by 4 p.m. You guessed it. Sign on to student.desmos.com. Here is your link, your code. This is my link, so don't click on that. Okay, that's my link actually. Don't click on that. But you can do student.desmos.com and do that. So this is basically going to help us kind of solidify in a visual aspect what are absolute value equations. And I hope it actually helps you maybe during the quiz tomorrow. So I'm going to just go through it just a little bit with you. Again, student.desmos.com. Make your own account if you haven't, and then type in this code. Or you can just click on that. All right. So I'm only going to go through a couple of these with you. I'm not going to go through the whole thing because it is actually very self-explanatory, and I want to get off the video and just have you guys work. So this is absolute value inequalities on a number line. Drag the blue point to a place on a number line, indicating that the number is at least 3 units away from -1. So 3 units away from -1. This is -1 right here, right? So I can move it here. That's 3 units, so 1, 2, 3. Or I can move it over here. So -1, 1, 2, 3. You see how it's totally different numbers? One of them was 2 and the other one was -4. Okay, so that's really easy. That's literally all you have to do. Seriously. It'd be a shame if you don't just drag a point and you lose actual points. Plot another point. Okay, another place on the number line, at least 3 units away from -1. So if I did -4, well then 3 units away from -1 would also be here. So you guys should all have this, -4 and 2. Move on to the next screen when you're done. So now, one more, at least 3 units away from -1. Okay, at least 3 units away from -1. So here's a tricky question. You may be thinking, wow, I already did that. This is kind of getting annoying. Why is it so annoying? Because think about it, at least 3 units. So if I say, hey, I'm going to give you at least $5, can I give you $5? You would probably say, yeah, Mr. Carlson, I'm game. But if I said, I can give you at least $5, is it $6 good enough as well? Isn't that sufficient? If I say I'm going to give you at least $5, but I give you $10, would that still suffice? Would that still be good? And you're like, heck yeah, like, what about $100? $2,000? If I give you at least $5, that means I can give you $5 and above. Okay, so at least 3 units away. So that means it could be 3 units this way, it could be 3 units that way, which we already marked, but it could also be 3 units past 2, maybe all the way over here. So that means any of these, where I'm kind of dragging my dot here, any of those work. Also, any of these work where I'm dragging my dot here, because that's also at least 3 units and above, far away from -1. Okay, because that's like the center. Okay, I hope that makes sense. I'm going to just leave it right there. Looks great. Nice work. So what would the graph look like if all your classmates were shown along yours? What do you think? Think about it. If all of you pointed all your dots either in this section or that section, what do you think would happen? I think I know what would happen. It would look something like shading. Okay, it would look something like shading. Okay, so it would literally look like all of this. It would look like a bunch of dots, and I know you're probably seeing this as you're kind of going through it. You can follow along, but it would look something like that. Doesn't that look like shading? Because it is. Okay, and so this is the purpose for inequalities. I'm going to share with the class. Oh boy. I'm going to go through a couple more with you, and then you guys can have the rest. Okay, now reveal. The graph here shows your blue points and your classmates' blue points in light blue. Obviously, I'm by myself, right? But you guys would see your light blue points. On the previous screen, you said shading because I was snarky. How does the actual graph compare to your prediction? I would say extremely well. How do I know that? Because I'm the math teacher. I know these things. Okay, it will look something like this. All this shading, because it would be a ton of dots. We have a lot of kids in our class, by the way. We have some 40 kids. So I'm pretty sure if all of you complete this, it's going to be a lot of freaking dots, I'm telling you. All right, one more, and then you guys have the rest. Now drag each blue point to a place on the number line, indicating that the number is now at most 4 units away. What does that mean? It's at most 4 units away from 2. So if this is 2, right? Okay, and that's 2. I want at most 4 units away from 2. So 1, 2, 3, 4. Okay, and then 4 units away from 2 this side is 6. So that means I can't go more than that. If I say I'm going to give you at most $5, can I give you 6? No, even though you'll want it, right? I can't give you 6 though. That's the problem, because it's at most. It's the top end. So now this actually looks like not an or inequality like the previous screens. This actually looks like an and inequality because it looks like it's going to combine in the middle. That's my winky face. Not really good. Okay, but that's what this Desmos activity does. It helps you kind of visualize what's happening and how it actually does it using at most and at least. So I think it's really helpful. It's easy 25 points. Make sure you complete that. Again, Here is the student.desmos.com. Get logged into here. If you don't ever know if something's due, guess what? You can look onto Synergy and it will definitely tell you what's next. I'm telling you. It will. After that, go ahead and work on the quiz review. It just has 2 lessons, the linear equations and inequalities, has absolute value equations and inequalities, but it also has some Algebra 1, like lines, linear lines, graphing, and stuff like that, okay? So I'm going to actually show you just maybe 1 or 2 examples of that, and you're like, you're killing us, Carlson. Well, I mean, I don't really feel like I am, to be honest. Will it say access denied? It will. I guarantee you. Oh my gosh, I told you. I told you. That means I have to, log back in and all that fun jazz. So, hope you guys' day was okay. Don't forget to check in with me. Check in every day with the Google form or email or on Google Meets. If I didn't see you on Google Meets, then you should be all up and down my business right now. Checking in. What the heck? Okay, let's go to the quiz review. I'm going to try it. This is what it'll look like. I want to show you some questions that you can expect to see on here, because these will be the questions that you'll expect to see. So you'll see something like this. Obviously, we've done this before. Very simple. Solve equations. Again, solve equations. That was the big one that we did about a couple days ago. Excuse me. This one is actually a really easy one. Okay, make sure you use be an example on this. It's only 6 parts. The hardest part is really just getting the equation. Okay, it starts with the absolute values. It keeps going through the absolute value equations. Here, I want to go through this question for you. Many of you probably are like, I don't know what to do here. This question is actually a really, really great question. You can still literally do the exact same thing. Okay, both sides are isolated. So my first equation is this. Literally exactly how I see it, except for no absolute value bars. My second equation is this. Exactly how I see it on the left side, but then on the right side, I want to make sure I use parentheses. Why am I going to use parentheses? Because remember, we have a negative that I need to tag on. So that's the only difference, and then I'll actually have to distribute that through, so that would be negative 6x, and then negative 1. This is 3x minus 15. I don't know why it's not working. If I move the 6x over here, the negative 6x, that'll become 9x. Add it over there, that'll become 16. 14. Wow, I'm awful. Why is this not working? Being really slow. It'll be 14, not 16. Yeah. Sweet. Okay, and then divide by 9, and you can go from there. Okay? So, I'm going to erase. I guess it doesn't want to erase. I think I'm killing it. I'm actually going to log out of this. So I'm killing it. But you get the picture. That's what it will look like. Okay? You get the picture. So do that as soon as possible. Other than that, you will take the quiz the next day or whenever you want to. As long as you're checking in with me. Honors contracts due on Friday. Math Excel orientation due Friday. We will have the quiz, and if you complete that review that I just showed you, that 15 questions at 100% before you take the quiz, you will receive up to 5 extra credit points. All right, that is all I have for you guys. Let me know if you have any questions. Keep rocking on and keep making great choices. Peace.